The Douglas DC-8 is a four-engine long-range narrow-body jet airliner built from 1958 to 1972 by the Douglas Aircraft Company. Launched after the competing Boeing 707, the DC-8 nevertheless kept Douglas in a strong position in the airliner market, and remained in production until 1972 when it began to be superseded by larger wide-body designs, including the Boeing 747, McDonnell Douglas DC-10 and Lockheed L-1011T TriStar. The DC-8's design allowed it a slightly larger cargo capacity than the 707, and some re-engined DC-8s are still in use as freighters. Development. Background. After World War II, Douglas had a commanding position in the commercial aircraft market. Boeing had pointed the way to the modern all-metal airliner in 1933 with the 247, but Douglas, more than any other company, made commercial air travel a reality. Douglas produced a succession of piston-engined aircraft through the 1930s, 1940s and 1950s. When de Havilland flew the first jet airliner, the Comet, in 1949, Douglas felt no need to rush into anything new. Their U.S. competitors at Lockheed and Convair felt the same way, that there would be a gradual switch from piston engines to turbines, and that the switch would be to the more fuel-efficient turboprop engines rather than pure jets. All three companies were working on a new generation of piston engine designs, with an eye to turboprop conversion in the future. De Havilland's pioneering Comet entered airline service in 1952. Initially it was a success, but it was grounded after several fatal crashes in 1953 and 1954. The cause of the Comet crashes had nothing to do with jet engines. It was a rapid metal fatigue failure brought on by cycling the high stresses in corners of the near-square windows from pressurizing the cabin to high altitudes and back. The understanding of metal fatigue that the Comet investigation produced would play a vital part in the good safety record of later types like the DC-8. In 1952, Douglas remained the most successful of the commercial aircraft manufacturers. They had almost 300 orders on hand for the piston-engine DC-6 and its successor, the DC-7, which had yet to fly. The Comet disasters, and the airline's subsequent lack of interest in jets, seemed to show the wisdom of their staying with propeller-driven aircraft. Competition. Boeing took the bold step of starting to plan a pure jet airliner as early as 1949. Boeing's military arm had gained experience with large, long-range jets through the B-47 Stratojet and the B-52 Stratofortress. With thousands of jet bombers on order or in service, Boeing had developed a close relationship with the U.S. Air Force's Strategic Air Command. Boeing also supplied the SAC's refueling aircraft, the piston-engine KC-97 Stratotankers, but these were too slow and low-flying to easily work with the new jet bombers. The B-52, in particular, had to descend from its cruising altitude and then slow almost to stall speed to work with the KC-97. Believing that a requirement for a jet-powered tanker was a certainty, Boeing started work on a new jet aircraft for this role that could be adapted into an airliner. As an airliner it would have similar seating capacity to the Comet, but its swept wing would give it higher cruising speed and better range. First presented in 1950 as the Model 473-60C, Boeing failed to generate any interest at the airlines. Boeing remained convinced that the project was worthwhile, and decided to press ahead with a prototype, the Boeing 367-80. After spending $16 million of their own money on construction, the -80 rolled out on May 15, 1954, and flew the next month. Boeing's plans became obvious, despite the misleading older model number. Design. Douglas secretly began jet transport project definition studies in mid-1952. By mid-1953 these had developed into a form similar to the final DC-8. An 80-seat, low-wing aircraft with 4 Pratt & Whitney JT3C turbojet engines, 30-degree wing sweep, and an internal cabin diameter of 11 feet to allow 5 abreast seating. Maximum weight was to be 95 tons, and range was estimated to be about 3,000 4,000 miles. Douglas remained lukewarm about the jet airliner project, but believed that the Air Force tanker contract would go to 2 companies for 2 different aircraft, as several USAF transport contracts in the past had done. In May 1954, the USAF circulated its requirement for 800 jet tankers to Boeing, Douglas, Convair, Fairchild, Lockheed, and Martin. Boeing was just 2 months away from having their prototype in the air. Just 4 months after issuing the tanker requirement, the USAF ordered the first 29 KC-135s from Boeing. Besides Boeing's ability to provide a jet tanker promptly, the flying boom air-to-air refueling system was also a Boeing product from the KC-97. Developing the KC-135 had been a safe bet. Donald Douglas was shocked by the rapidity of the decision which, he said, had been made before the competing companies even had time to complete their bids. He protested to Washington, but without success. Having started on the DC-8 project, Douglas decided that it was better to press on than give up. Consultations with the airlines resulted in a number of changes. The fuselage was widened by 15 inches to allow 6 abreast seating. This led to larger wings and tail surfaces and a longer fuselage. The DC-8 was announced in July 1955. 4 versions were offered to begin with, all with the same 150-foot-6-inch long airframe with a 141-foot-1-inch wingspan, but varying in engines and fuel capacity, and with maximum weights of about 120 tons. Douglas steadfastly refused to offer different fuselage sizes. The Maiden Flight was planned for December 1957, with entry into revenue service in 1959. Well aware that they were lagging behind Boeing, Douglas began a major push to market the product. First orders, Douglas' previous thinking about the airliner market seemed to be coming true. The transition to turbine power looked likely to be to turboprops rather than turbojets. The pioneering 40-60-seat Vickers Viscount was in service and proving popular with passengers and airlines. It was faster, quieter and more comfortable than piston engine types. Another British rival was the 90-seat Bristol Britannia, and Douglas's main rival in the large airliner market, Lockheed, had committed to the short-medium-range 80-100-seat turboprop Electra, with a launch order from American Airlines for 35 and other orders flowing in. Meanwhile the Comet remained grounded. The French 90-passenger twin-jet Sud Aviation Caravelle prototype had just flown for the first time, and the 707 was not expected to be available until late 1958. The major airlines were reluctant to commit themselves to the huge financial and technical challenge of jet aircraft. However, no one could afford not to buy jets if their competitors did. There the matter rested until October 1955, when Pan American placed simultaneous orders with Boeing for 2707s and Douglas for 25 DC-8s. To buy one expensive and untried jet-powered aircraft type was brave, to buy both was at the time, unheard of. In the closing months of 1955, other airlines rushed to follow suit. Air France, American, Braniff, Continental and Sabine ordered 707s. United, National, KLM, Eastern, JAL and SAS chose the DC-8. In 1956 Air India, BOAC, Lufthansa, Qantas and TWA added over 50 to the 707 order book, while Douglas sold 22 DC-8s to Delta, Swissair, TAI, TransCanada and UAT. By the start of 1958, Douglas had sold 133 DC-8s compared to Boeing's 157 07s. Basic price of a JT4-powered domestic version of the DC-8 was around $5.46 million in 1960. Production and testing. Donald Douglas proposed to build and test the DC-8 at Santa Monica Airport, which had been the birthplace of the DC-3 and the site of a Douglas plant that employed 44,000 workers during World War II. In order to accommodate the new jet, however, Douglas asked the city of Santa Monica, California to lengthen the airport's 5,000-foot runway. Bowing to the complaints of residents living near the airport, the city refused, so Douglas moved the company's airliner production line to Long Beach Airport. The first DC-8 N8008D was rolled out of the new factory at Long Beach on April 9, 1958 and flew for the first time, in Series 10 form, on May 30 for 2 hours 7 minutes, with the crew being led by A.G. Heimerdinger. Later that year an enlarged version of the Comet finally returned to service, but too late to take a substantial portion of the market. De Havilland had just 25 orders. In August Boeing had begun delivering 707s to Pan Am. Douglas made a massive effort to close the gap with Boeing, using no less than 10 aircraft for flight testing to achieve FAA certification for the first of the many DC-8 variants in August 1959. Much was needed to be done. The original air brakes on the lower rear fuselage were found ineffective and were deleted as engine thrust reversers had become available. Unique leading-edge slots were added to improve low-speed lift. The prototype was 25 kn short of its promised cruising speed, and a new, slightly larger wingtip had to be developed to reduce drag. In addition, a recontoured wing leading edge was later developed that extended the chord 4% and reduced drag at high Mach numbers. The DC-8 entered service with Delta Airlines on September 18, 1959, with United entering service later the same day. By March 1960 Douglas had reached their planned production rate of 8 DC-8s a month. Despite the large number of DC-8 early models available, all used the same basic airframe, differing only in engines, weights and details. In contrast, Boeing's rival 707 range offered several fuselage lengths and 2 wingspans, the original 144-foot 707-120. A 135-foot version that sacrificed space to gain longer range, and the stretched 707-320, which at 153 feet overall had 10 feet more cabin space than the DC-8. Douglas' refusal to offer different fuselage sizes made it less adaptable and forced Delta and United to look elsewhere for short-medium-range types. Delta ordered Convair 880s, but United went for the newly developed lightweight 707-020 but prevailed on Boeing to rename the new variant the 720 in case people thought they were dissatisfied with the DC-8. Significantly, Pan Am never reordered the DC-8 and Douglas gradually lost market share to Boeing. After an excellent start, 1962 DC-8 sales dropped to just 26, followed by 21 in 1963 and 14 in '64, and most of these were for the jet trader rather than the more prestigious passenger versions. In 1967, Douglas merged with McDonnell Aircraft Corporation to become McDonnell Douglas. On August 21, 1961, a Douglas DC-8 broke the sound barrier at Mach 1.012 while in a controlled dive through 41,000 feet and maintained that speed for 16 seconds. The flight was to collect data on a new leading-edge design for the wing, and while doing so, this DC-8 became the first civilian jet, and the first jet airliner, to make a supersonic flight. The aircraft was a DC-8-43 later delivered to Canadian Pacific Airlines as CFC-PG. The aircraft, crewed by Captain William Magruder, First Officer Paul Patton, Flight Engineer Joseph Tomich and Flight Test Engineer Richard Edwards, took off from Edwards Air Force Base in California, and was accompanied to altitude by an F-104 flown by Chuck Yeager. Further developments. In April 1965, Douglas announced belated fuselage stretches for the DC-8 with 3 new models known as the Super 60s. The DC-8 program had been in danger of closing with fewer than 300 aircraft sold, but the Super 60s brought fresh life to it. By the time production ceased in 1972, 262 of the stretch DC-8s had been made. With the ability to seat 269 passengers, the DC-8 Series 61 and 63 had the largest passenger carrying capacity available. That remained so until the Boeing 747 arrived in 1970. All the earlier jetliners were noisy by modern standards. Increasing traffic densities and changing public attitudes led to complaints about aircraft noise and moves to introduce restrictions. As early as 1966, the New York Port Authority expressed concern about the noise to be expected from the then still unbuilt DC-8-61, and operators had to agree to operate it from New York at lower weights to reduce noise. By the early 1970s, legislation for aircraft noise standards was being introduced in many countries, and the 60 series DC-8s were particularly at risk of being banned from major airports. In the early 1970s, several airlines approached McDonnell Douglas for noise reduction modifications to the DC-8, but nothing was done. Third parties had developed aftermarket hush kits, but there was no real move to keep the DC-8 in service. Finally, in 1975, General Electric began discussions with major airlines with a view to fitting the new and vastly quieter Franco-American CFM56 engine to both DC-8s and 707s. MDC remained reluctant but eventually came on board in the late 1970s and helped develop the Series 70. The Super 70s were a great success, roughly 70% quieter than the 60 series and, at the time of their introduction, the world's quietest four-engined airliner. As well as being quieter and more powerful, the CFM56 was roughly 20% more fuel efficient than the JT3D, which reduced operating costs and extended the range. By 2002, of the 1,032 707s and 720s manufactured for commercial use, just 80 remained in service though many of those 707s were converted for USAF use either in service or for spare parts. Of the 556 DC-8s made, around 200 were still in commercial service in 2002, including about 25 50 series, 82 of the stretched 60 series, and 96 out of the 110 re-engined 70 series. Most of the surviving DC-8s are now used as freighters. In May 2009, 97 DC-8s were in service following UPS's decision to retire their remaining fleet of 44. In January 2013, an estimated 36 DC-8s were in use worldwide. As a result of aging, increasing operating costs and strict noise and emissions regulations, the number of active DC-8s continues to decline. Variants, Series 10, for domestic use, powered by 13,500 lb Pratt & Whitney JT3C6 turbojets with water injection. The initial DC-8-11 model had the original, high-drag wingtips and all were converted to DC-8-12 standard. The DC-8-12 had the new wingtips and leading-edge slots, 80 inches long between the engines on each wing and 34 inches long inboard of the inner engines. These unique devices were covered by doors on the upper and lower wing surfaces that opened for low-speed flight and closed for cruise. The maximum weight increased from 265,000 pounds to 273,000 pounds. 28 DC-8-10s were built. This model was originally named DC-8A until the Series 30 was introduced. 29 built, 22 for United and 6 for Delta, plus the prototype. By the mid-60s, United had converted 15 of its 20 surviving aircraft to DC-8-20 standard and the other 5 to -50s. Delta converted its 6 to DC-8-50s. Series 20, higher-powered 15,800 lb thrust Pratt & Whitney JT4A3 turbojets allowed a weight increase to 276,000 pounds. 34 DC-8-20s were built plus 15 converted DC-8-10s. This model was originally named DC-8B, but was renamed when the Series 30 was introduced. Series 30, for intercontinental routes, the 3 Series 30 variants combine JT4A engines with a 1/3 increase in fuel capacity and strengthened fuselage and landing gear. The DC-8-31 was certified in March 1960 with 16,800 lb JT4A9 engines for 300,000 pound maximum takeoff weight. The DC-8-32 was similar but allowed 310,000 pound weight. The DC-8-33 of November 1960 substituted 17,500 lb JT4A11 turbojets, a modification to the flap linkage to allow a 1.5° setting for more efficient cruise, stronger landing gear, and 315,000 pound maximum weight. Many -31 and -32 DC-8s were upgraded to this standard. A total of 57 DC-8-30s were produced. Series 40. The DC-8-40 was essentially the -30 but with 17,500 lb Rolls-Royce Conway 509 turbofan engines for better efficiency, less noise and less smoke. The Conway was an improvement over the turbojets that preceded it, but the Series 40 sold poorly because of the traditional reluctance of U.S. airlines to buy a foreign product and because the still more advanced Pratt & Whitney JT3D turbofan was due in early 1961. The DC-8-41 and DC-8-42 had weights of 300,000 and 310,000 pounds respectively. The 315,000-pound DC-8-43 had the 1.5-degree flap setting of the -33 and introduced a 4% leading-edge wing extension to reduce drag and increase fuel capacity slightly. The new wing improved range by 8%, lifting capacity by 3.3 tons, and cruising speed by better than 10 knots. It was used on all later DC-8s. The first DC-8-40 was delivered in 1960. 32 were built. Series 50, the definitive short fuselage DC-8 with the same engine that powered the vast majority of 707s, the JT3D. 14 earlier DC-8s were converted to this standard. All but the -55 were certified in 1961. The DC-8-51, DC-8-52 and DC-8-53 all had 17,000 lb JT3D1 or 18,000 lb JT3D3B engines, varying mainly in their weights, 276,000 pounds, 300,000 pounds and 315,000 pounds respectively. The DC-8-55 arrived in June 1964, retaining the JT3D3B engines but with strengthened structure from the freighter versions and 325,000-pound maximum weight. 88 DC-8-50s were built plus the 14 converted from Series 10/30. DC-8 Jet Trader, Douglas approved development of freighter versions of the DC-8 in May 1961, based on the Series 50. An original plan to fit a fixed bulkhead separating the forward A of the cabin for freight, leaving the rear cabin for 54 passenger seats was soon replaced by a more practical one to use a movable bulkhead and allow anywhere between 25 and 114 seats with the remainder set aside for cargo. A large cargo door was fitted into the forward fuselage, the cabin floor was reinforced and the rear pressure bulkhead was moved by nearly 7 feet to make more space. Airlines could order a windowless cabin but only United did, ordering 15 in 1964. The DC-8-54 had a maximum takeoff weight of 315,000 pounds and the DC-8-55 325,000 pounds. Both used 18,000 lb JT3D3B powerplants. 54 aircraft built. EC-24A, a single former United Airlines DC-8-54 was used by the United States Navy as an electronic warfare training platform. It was retired in October 1998 and is now in storage with the 309th Aerospace Maintenance and Regeneration Group. Super 60 Series, DC-8 Series 61, the Series 61 was designed for high capacity and medium range. It had the same wings, engines and pylons as the -55, and sacrificed range to gain capacity. Having decided to stretch the DC-8, Douglas inserted a 240-inch plug in the forward fuselage and a 200-inch plug aft, taking overall length to 187 feet 4 inches. The added length required strengthening of the structure, but the basic DC-8 design already had sufficient ground clearance to permit the 1/3 increase in cabin size without requiring longer landing gear. The variant first flew on March 14, 1966 and was certified on September 2, 1966 at a maximum weight of 325,000 pounds. Deliveries began in January 1967 and it entered service with United Airlines in February 1967. It typically carried 180 220 passengers in mixed-class configuration, or 259 in high-density configuration. A cargo door-equipped DC-8-61CF was also available. 78-61 and 10-61CF were built. DC-8 Series 62, the long-range Series 62 followed in April 1967. It had a more modest stretch, two 40-inch plugs fore and aft of the wing taking overall length to 157 feet 5 inches, and a number of modifications to provide greater range. 3-feet wingtip extensions reduced drag and added fuel capacity, and Douglas redesigned the engine pods, extending the pylons and substituting new shorter and neater nacelles, all in the cause of drag reduction. The 18,000 LBJT-3D-3B was retained, but the engine pylons were redesigned to eliminate their protrusion above the wing and make them sweep forward more sharply, so that the engines were some 40 inches further forward. The engine pods were also modified with a reduction in diameter and the elimination of the -50 and -61 bypass duct. The changes all improved the aircraft's aerodynamic efficiency. The DC-8 Series 62 is slightly heavier than the -53 or -61 at 335,000 pounds, and able to seat up to 189 passengers. The -62 had a range with full payload of about 5,200 nautical miles, or about the same as the -53 but with 40 extra passengers. Many late production -62s had 350,000 pounds maximum takeoff weight and were known as the -62H. Also available is the cargo door-equipped convertible -62CF or all-cargo -62AF. 51 DC-8-62s were built plus 10-62CF and 6-62AF. DC-8 Series 63. The Series 63 was the final new-build variant and entered service in June 1968. It had the long fuselage of the -61, the aerodynamic refinements and increased fuel capacity of the -62 and 19,000 LBJT-3D-7 engines. This allowed a maximum takeoff weight of 350,000 pounds and a range with full payload of 4,110 nautical miles. Like the -62, the Series 63 was also available as a cargo door-equipped -63CF or all-cargo -63AF. The freighters had a further increase in maximum takeoff weight to 355,000 pounds. Eastern Airlines bought 6-63PFs with the strengthened floor of the freighters but no cargo door. 41 DC-8-63s were built, plus 53-63CF. 7-63AF and the 6-63PFs. The Flying Tiger line was a major early customer for the DC-8-63F. Super-70s. The DC-8-71 to DC-8-73 were straightforward conversions of the -61 to -63, replacing the JT3D engines with more fuel-efficient 22,000 lbcfm 56-2 high-bypass turbofans and new housings built by Grumman, along with new engine pylons and fairing of the air intakes below the nose. The DC-8-71 achieved the same end but required more modification because the -61 did not have the improved wings and relocated engines of the -62 and -63. Maximum takeoff weights remained the same, but there was a slight reduction in payload because of the heavier engines. All three models were certified in 1982 and a total of 110 60 Series DC-8 seconds were converted by the time the program ended in 1988. Operators. A total of 17 DC-8s were in service as of June 2014 with the following operators, accidents and incidents. As of May 2011, the DC-8 had been involved in 140 incidents, including 83 hull loss accidents, with 2,256 fatalities. The DC-8 has been in 46 hijackings involving 2 fatalities. Aircraft on display. The following museums have DC-8s on display or in storage: California Science Center, Los Angeles, an ex-United Airlines Douglas DC-8-52 and 8066U on display outside near downtown, Aviodrome Museum, Lelystad Airport, Netherlands, XMK Airlines Douglas DC-8 preserved as KLM Airlines PHDCZ, Naval Air Museum Barbers Point Kalaeloa Airport, Hawaii, X-Air Transport International Douglas DC-8 on display. N799AL. Ex-United Airlines DC-8-21 used by ORBIS International as a flying eye hospital is now located at Chinese Aviation Museum in Daitangshan, China. Specifications. Sources, deliveries, see also. Related development, Douglas DC-9, aircraft of comparable role, configuration and era, Boeing 707, de Havilland Comet, Convair 990, Ilyushin Il-62, Shanghai Y-10, 2 Polov to 114, Vickers VC-10, related lists, list of civil aircraft, references, notes. Bibliography. Further reading, Kelly, George Walker. The Douglas DC-8, A Pictorial History. Dallas, G. W. Kelly, Jr., 1992. Douglas Aircraft Company. The DC-8 Story, Long Beach, California, Douglas Aircraft Company, 1972. Douglas Aircraft Company. Douglas DC-8 Maintenance Manual. Long Beach, California, Douglas Aircraft Company, 1959. OCLC 10,621,428. Francillon, Rena. Copyright McDonnell Douglas Aircraft since 1920. London, Putnam, 1979. ISBN 0-370-00050-1. Hubeler, Richard G. Big 8, A Biography of an Airplane. New York, Duell, Sloan, and Pierce, 1960. Lundqvist, Bogeran. Douglas DC-8. Coral Springs, Florida, Lundqvist Aviation Research, 1983. OCLC 62,220,710. McDonnell Douglas. The DC-8 Super 60. Long Beach, California, McDonnell Douglas Corporation. Sales Engineering Divide, 1968. McDonnell Douglas. The DC-8 Handbook. Long Beach, California, McDonnell Douglas Corporation. Sales Engineering Divide, 1982. Norris, Guy, and Wagner, Mark. Douglas Jetliners. Osceola, Wisconsin, MBI Publishing, 1999. ISBN 0-7603-0676-1. Proctor, John, Mishat, Mike, Codetta, Craig. From Props to Jets, Commercial Aviation's Transition to the Jet Age 1952 to 1962. North Branch, Minnesota, Specialty Press. ISBN 1-58007-146-5. Vicenzi, Hugo. Early American Jetliners, Boeing 707, Douglas DC-8 and Convair Cove 880. Osceola, Wisconsin, MBI Publishing. ISBN 0-7603-0788-1. Waddington, Terry. Douglas DC-8. Miami, Florida, World Transport Press, 1996. ISBN 0-9626730-5-6. Wilson, Stuart. Airliners of the World. Fyshik, Australia, ACT, Aerospace Publications Proprietary Limited, 1999. ISBN 1-875671-44-7. Wilson, Stuart. Boeing 707, Douglas DC-8, and Vickers VC-10. Fyshik, Australia, ACT, Aerospace Publications Proprietary Limited, 1998. ISBN 1-875671-36-6. External links, DC-8 page on airliners.net, DC-8 Airborne Laboratory Fact Sheet on NASA Dryden FRC's site.